Here, the intervals would be defined. The endpoints of the curve would be defined. Here, it is represented by A and B. A and B are the endpoints. In order to find out a definite integral, first we have to find out an integral of a function which is given to us, and then comes the next step, which is only used for definite integrals. And here we have to substitute the value of b as in the upper limit. This is also known as the upper limit, and this is known as the lower limit. We have to substitute both of the values and subtract both of them in order to get a particular value for the same. And you have to note one thing, that here we need not add c. Usually in indefinite integrals we add c whenever we integrate. Here we need not add c, right? So the area under this particular curve bounded by the region of a and b on the x-axis is written down as integral of a to b, integral from a to b f of x dx, or integral of f of x dx from a, right? Is that clear? I hope this is clear, and let's move on. I will start by taking an example over here, right? So to give you a better idea how this works. So in order to demonstrate the same, I have taken up a straight line. A straight line is also a curve, and area under this particular curve would be area of this particular triangle. So let me start by finding out the area of this particular triangle. Area of the triangle is given by half multiplied by base multiplied by height. Here, the base and height is 4. So half multiplied by 4 multiplied by 4, the area would be 8 units squared. Similarly, we can use definite integrals also in order to find out the area under the curve. A straight line is also a curve, and this curve, the formula or the equation for this curve would be y is equal to x. Now I have to integrate this particular function from 0 to 4. This is the lower limit, this is going to be the upper limit, and I'll show you how this works. And here also I'll be getting the area, I should be getting the area as 8. So I will start by integrating x with respect to dx, because the equation of this particular curve is x. It can be anything else as well. We can have x or x plus 2 or x squared plus 2. We can have any curve. We just have to integrate that from a to b. Here the value of a is 0. It is starting out from 0 and it is ending at 4. So integral of x is x squared over 2. You have to now substitute the value of a and b. When I substitute the value of b over here first, 4 raised to the power of 2 over 2 minus a raised to the power of 2 over 2. A is 0 over here, 0 is to the power of 2 over 2. When I substitute, and I will simplify, I should be getting the same answer. 16 raised to the power 16 over 2, which is going to be 8 units squared again, right? So this is how definite integrals work.
On both.
Now, yes, you had any question? I heard something.
No, no, sir. I'm sorry. I accidentally unmuted.
Okay, not a problem. So now let us get started by solving few questions so that we'll be getting a better idea. The first question is integral of x squared with respect to dx from 1 to 3. So first, let me start by integrating x squared. When I integrate x squared, I would be getting x raised to the power of 3 over 3. Now I have to substitute the value of 3, substitute the value of 1, and subtract both of them. I should be getting my answer. When I substitute the value of 3, it will be 3 raised to the power of 3 over 3 minus 1 raised to the power of 3 over 3. So when I simplify, it is going to be 27 over 3 negative 1 over 3. So the final value is going to be equal to 26 over 3. Integral of x squared with respect to dx from 1 to 3 is going to be 26 over 3. Let's move on to the next one. Integral of root x with respect to dx from 0 to 25. I can write square root of x as x raised to the power of half. Now again I can use the power rule of integration. So it is going to be x raised to the power of half plus 1 over half plus 1 from 0 to 25. So let me simplify the powers of x first. X raised to the power of 3 over 2 divided by 3 over 2. This 3 over 2 can be taken out, and I can write this as 2 over 3. Since this is a constant, it can be taken out. And now I have to substitute the value of 0 and 5 in place of x. When I do that, I will be getting 2 over 3 as it is. 25 raised to the power of 3 over 2 negative 0 raised to the power of 3 over 2. 0 raised to the power of anything is 0, so I can ignore this. Now 2 over 3 multiplied by 25 3 over 2 can be written down as 5 raised to the power of 2. 25 can be expressed as 5 raised to the power of 2 whole raised to the power of 3 over 2. Now the powers can be cancelled out, so you'll be getting 5 raised to the power of 3. 2 over 3 multiplied by 5 raised to the power of 3. 5 raised to the power of 3 is 125. 2 multiplied by 125 over 3, which is 250 over 3. Integral of square root of x from 0 to 25 would be 250 over 3. This is going to be your final answer. I hope this is clear, and let me move on to the next one. Integral of 1 over square root of x from 4 to 9. Again, I will express this in powers of, in negative powers. I can express this as x raised to the power of negative half, and I'll be using the power rule first. When I use that, x raised to the power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1, and here I have to substitute the limits as 9 and 4. When I simplify, I should be getting x raised to the power of half divided by 1 over 2, and 1 over 2 is a constant. That can be taken out, and when I take that out, it is going to be equal to 2. 2 multiplied by x raised to the power of half, or also x raised to x square root of x, both are one and the same. From 9 to 2, I will substitute the value of 9 and 4. 2 multiplied by square root of 9, square root of 2 is going to be 3, and 2, when I subtract both of them, it is going to be 1. 2 multiplied by 1, the value of integral 1 over square root of x from 4 to 9 is going to be equal to 2. Let's move on to the next question, and I will be taking up a trigonometric question later on as well. Integral of e raised to the power of negative x from 0 to infinity with respect to dx. Let us start by integrating e raised to the power of negative x. E raised to the power of negative x, when integrated, you will be getting negative e raised to the power of negative x. Now I should be substituting the value of infinity and 0 in place of x. Negative sign can be taken out. E raised to the power of negative infinity minus e raised to the power of negative 0. When I substitute, I should be getting 0 as it is. E raised to the power of infinity is 0, negative sign as it is, minus sign as it is, and e raised to the power of 0 or negative 0, it does not really matter. It is going to be equal to 1. Negative sign and negative sign, when multiplied, I'll be getting a positive sign. So when I integrate e raised to the power of negative x with respect to dx from 0 to infinity, the value is going to be equal to 1. Let us take up one more question, and then let us take up a few more questions which are based on trigonometry as well. Integrate sine 2x with respect to dx from 0 to pi over 2. Let us start by integrating sine 2x. When I integrate sine 2x, I'll be getting negative 1 over 2 cos 2x from 0 to pi over 2. Now I have to substitute the value of pi over 2 in place of x. Negative 1 over 2 as it is, cos 2 multiplied by pi over 2 minus cos 2 multiplied by 0. I'm just substituting the value of pi and 0 in place of x. Now let me simplify. When I simplify, I will be getting negative half as it is on the outside, cos pi minus cos 0. Negative half outside, negative cos pi is negative 1, cos 0 is negative 1. Cos 0 is 1, negative sign and 1 would be getting, I will be getting the value as negative 1. So when I add these both, negative 1 and negative 1, I would be getting negative 2. Negative 1 and negative 2, when multiplied, I'd be getting 2. 2 over 2, the value is again equal to 1, which means integral of sine 2x with respect to dx from 0 to pi over 2 is going to be equal to. I hope this is clear. Let's move on to the next one, and here I will take up sine square x with respect to dx. It is not sine 2x, and again it's going to be from 0 to pi over 2. Now can we integrate this directly? No, we cannot, right? I have to use half angles, and when I do that, I can express this as integral of 0 to pi over 2 as it is, and half multiplied by 1 minus cos 2x with respect to dx. Now I can integrate using which rule? integration by parts,
Zero.
right? Half as it is, so I will start by taking half as it is, and this is going to be multiplied by x, and over here, because the integral of 1, right? So it is going to be x as it is, and this is going to be from 0 to pi, minus it is going to be half sine 2x, the integral of cos 2x, and even this is going to be from 0 to pi, pi by 2, pi by 2. So half as it is on the outside, and this is going to be multiplied by pi over 2 as it is, and when I substitute 0, it is going to be 0, so I can ignore this one, right? And negative half as it is, and here it is going to be sine 2x, as in I should multiply sine 2 multiplied by pi over 2 minus sine 2 multiplied by 0. Now the value is going to be half multiplied by pi over 2 as it is, minus 1 over 2 as it is, and it is going to be multiplied by sine pi minus sine 0. I hope you are able to follow. Sine 0 is 0, sine pi is 0 as well. So I can ignore this particular term, and half multiplied by pi over 2 is going to be your final answer. So integral of sine square x dx from 0 to pi over 2 is going to be equal to pi over, and this is going to be your final expression. Let's move on to other problems as well. Similarly, I can solve for cos square x, and let me do that over here. Cos square x with respect to dx from 0 to pi over 4. Again, I cannot integrate this directly. I have to use double angles, and when I do that, I can express this as 0 to pi over 2 as it is, and cos square x can be written down as half multiplied by 1 plus cos 2x with respect to dx. Again, you can integrate using parts, so half multiplied by, it is going to be x, and this is from 0 to pi over 2, right? We have to substitute this value, and then it is going to be plus half sine 2x, and here also I have to substitute 0 and pi over 2. I hope this is clear. Yeah, we can just integrate them separately, and we can get our answer. So half as it is, and this is going to be multiplied by pi over 2 now, and minus 0 when I substitute, plus half as it is, and now I have to substitute the value of 2 multiplied by pi over 2 minus sine 2 multiplied by 0. So essentially, this is going to be equal to 0 again. So half multiplied by pi over 2 minus 0 is going to be 0, plus half multiplied by, here it is going to be sine pi minus sine 0. Sine pi is 0, sine 0 is also 0. 0 multiplied by anything is 0. So again, this term will be getting cancelled out. So cos square x with respect to dx, the integral from 0 to pi over 4 is again pi over, sorry, this is pi over 2, this is pi over 2, okay, my bad. Again, we are using the double angle formula. I hope you are getting an idea. Let me take up one more problem over here. Square root of 1 plus sine x with respect to dx, and we have to integrate this from 0 to pi over 2. Again, I'll be using half angle or the double angle formula. I can express 1 as, so the integral of 0 to pi over 2 as it is, and the square root also as it is. 1 can be expressed as sine square x over 2 plus cos square x over 2, and sine x can be expressed as 2 sine x over 2 multiplied by cos x over 2. We are using the double angle or the half angle formula. Both are one and the same with respect to dx now. Yeah. Now this is of the form a plus a square plus b square plus 2ab. So I can express this as 0 to pi over 2, and this is the square root of sine x over 2 plus cos x over 2 whole raised to the power of 2 with respect to dx. Now you can simplify the square and the square root. So you will be left out with sine x over 2 and cos x over 2. So this is going to be integral of 0 to pi over 2 integral sine x over 2 with respect to dx, and I will be adding 0 to pi over 2 cos x over 2 with respect to dx as well. Now when I integrate sine x over 2, I will be getting 2 cos x over 2, of course with a negative sign, negative 2 cos x over, yeah, and here it is going to be 2 sine x over 2. I have to substitute the value of pi and 0, both of them I have to substitute, and I should be getting my answer. So here it is going to be negative cos, negative 2 cos as it is, and multiplied by x over 2 is now substituted as pi over 2 divided by 2 minus 0 divided by 2 plus 2 sine of, right, this is going to be x over 2. Yeah. Yes, again you will be writing down pi over 2 over 2 minus 0. So the final value is going to be equal to negative 2 cos, right? Cos here it is going to be pi over 2 over 2. You will be getting cos pi by 4. So how will I write? Okay, so 2 I will take it outside. So this is going to be cos pi over 2 minus cos 0 plus again 2 is going to be outside, and here it is going to be pi over 4 negative sine and 0. Sine 0 is going to be equal to 0. So I don't think I have space over here. So let me go to the next slide. And here it was 2 as it is multiplied by, it was sine cos pi by 2. It is 1 cos pi by 4. So it is 1 over square root of 2 minus cos 0 is 1, and it is going to be plus 2 multiplied by 1 over square root of 2 pi over 2, and here it is going to be sine 0 is 0. Yeah, I hope it's clear.
Yes,
Now
sir.
when I simplify this, you will be getting 2 over square root of 2 minus 2 plus 2 over square root of 2, and here 0 can be ignored. 0 can be ignored. Now when you add, you will be getting 4 over square root of 2 minus, okay. Can I simplify this further? Can this be
Root
simplified?
2,
Oh, wait.
root
This is
2.
going to be one second, one second. My bad. This is negative, right? So it will be getting cancelled out. It will be getting cancelled out. This is negative. If this was negative, I didn't take negative sign. So this is negative. In that case, negative 2 over square root of 2 plus 2, and here plus 2 square root of 2 plus or 0. Negative 0 does not really matter. So cancel these. So you would be ending up with 0, which means the integral of 0 to pi over 2 square root of 1 plus sine x with respect to dx. is going to be equal to 2, and this is going to be your final. I had started from here. I don't think I thought I would be able to be finishing on the same slide, but I'm not able. So this is how you'll be. So, and we have a few more questions, and we can use integration by parts as well over there. So let us take up a simple question over here, which is based on log, right? Integral of log of x with respect to dx from 1 to 2. And now I can express this as 1 multiplied by log x with respect to dx, integral of 1 integral from 1 to 2. Here the first term can be taken as log of x, so the first term as it is, right? And it is going to be multiplied by x, and now x is from 1 to 2 minus the integral of log of x. Log of x is going to be differential. It is going to be 1 over x multiplied by x with respect to dx. So let me solve this further. So it is going to be x, and here it is x multiplied by, once again, log x as it is, and integral. So it is going to be I will write down x log x log of x, and here it is, even this is from where to where, both of them are from 2 to 1, and minus, here it is going to be x and x will be getting cancelled out, minus x, and here also it is from 1 to. So let me substitute the same. So when 2 is substituted, it is going to be 2 log 2 minus 1 log 1 minus, here it is going to be 2 minus 1. So over here the final value is going to be 2 log 2 as it is, log 1 anyway it is going to be 0, negative 2 minus 1 is going to be 1, negative 1 is going to be your final answer. So I should be getting integral of 1 to 2 log of x with respect to dx as 2 log of 2 minus 1. This is going to be your final answer. So this was based on log. Let me take up one more, which is based on integration on of parts. Integral of 0 to 1 x multiplied by e raised to the power of x with respect to dx. So first let me start by integrating the same e raised to the power of x, the first term as it is, right? Or x as it is, and I will take up x because I late, right? So e should be at the last. So x as it is, and this is multiplied by integral of e raised to the power of x. It is going to stay e raised to the power of x, and the limits are from 0 to 1. And now minus integral of, again, 0 to 1 e raised to the power of x as it is, and the differential of x is going to be 1 with respect to dx. So when I simplify this, I should be getting x raised to the power x multiplied by e raised to the power of x from 1 to 0. I will apply the limits, minus, again here I would be getting e raised to the power of x from 0 to 1, because when I integrate e raised to the power of x, it is going to stay e raised to the power of x. Now let me substitute the value of 1 and 0. When I do that, 1 multiplied by e raised to the power of 1 minus 0 multiplied by e raised to the power of 0 minus, here it is going to be e raised to the power of 1 minus e raised to the power of 0. So over here the value is going to be to e as it is. Here it is minus e. Here it is again e raised to the power of 1. So it is going to be 1 over, here it's 0, and e raised to the power of 0 is going to be 1. Negative sign and negative sign, I'll be getting 1. E raised to the power of 1 is 0. Okay, so e and e can be cancelled out, so you would be left out with 1, which means integral of 0 to 1 x multiplied by e raised to the power of x with respect to dx is just 1. And let me put a box around it.